Hi, this is Sir Amboy, and welcome once again to my lecture series in electromagnetics. In the previous episode, we discussed Gauss's law and learned how to use it to calculate electric fields. Now, in this episode, we will learn a new mathematical concept that is very essential in the study of electromagnetics and is closely related to Gauss's law in particular. That is the concept of the divergence. We will also learn about a powerful mathematical theorem called the Divergence Theorem and use it to derive one of the four Maxwell's equations. That is the Maxwell's equation that represents Gauss's law. And then after the discussion of the concepts and theories, I will solve 4 sample problems and leave you with an exercise problem para may mapagpractice naman kayo. O, diba? So, if you're ready, let's get started. To illustrate the concept of the divergence, consider a closed surface containing electric charges inside of it. Okay, so this closed surface has charges inside of it. And because there are charges inside, meron siyang tinatawag na volume charge density. So this rho v is the volume charge density, which is measured in coulombs per cubic meter. And because there are charges inside, there must be electric field in this region. Now let that electric field be represented by the vector D, which is the electric flux density. Instead of using the electric field intensity E, we used D for more convenience, as you will see later. And because there are electric fields, then we can use electric field lines to visualize them. So these are the electric field lines, which we call electric flux, which we can use to visualize the electric field. And mathematically, we can calculate the net flux through this entire closed surface. Remember our discussion of the electric flux? The electric flux can be determined by calculating the surface integral of D. Okay? Because the electric flux is the flux of the vector D. So that means that the net flux here is just the surface integral of D. So yan palang electric flux na yan ay mga ka-DDS. Diba? Charot! No comment. So once again, the net electric flux through this entire closed surface is the surface integral of the flux density, no? D dot ds. Now, can you imagine what will happen if this closed surface gets smaller and smaller? Ano kaya ang mangyayari kapag ang surface na ito ay pinaliit natin ng pinaliit? Sir, bakit mo kailangang paliitin yung surface? Because we want to illustrate the concept of the divergence. So that is necessary. Kailangan nating paliitin ng paliitin ang closed surface na ito para ma-illustrate ang concept ng divergence. So now, can you imagine? Ano ang mangyayari kung ito ay paliliitin natin ng paliliitin? Let's take a look. Ayan. Pag pinaliit natin ang closed surface, of course, dahil may laman siyang charges sa loob, meron pa rin tayong electric flux na makukuha dyan, na tumatagos doon sa closed surface. At kung papaliitin pa natin yan ng paliliitin, ayan, eto na siya ngayon. Lumiliit siya ng lumiliit. So ultimately, kung paliit siya ng paliit, ano ang kanyang ina-approach? Pag lumiit siya ng lumiit, darating ang point kung saan isa na lang siyang point. Diba? Na walang dimension. Okay? And once the closed surface has zero volume, essentially, it is now a point. Just like this. So what will now happen to the total flux as the volume of the closed surface shrinks to zero? Okay, so kanina meron tayong isang closed surface na nagtataglay ng mga electric charges sa loob. And to illustrate the concept of the divergence, pinaliit natin ng pinaliit yung closed surface hanggang sa ang kanyang volume ay maging zero na, and essentially it is now a point. So this tells us that we are bound to find the flux at a point. Kukuhanin natin kung gaano karaming flux ang nag-e-emanate doon sa point na ito. And to do this, we need to divide the total flux by the volume. So remember that the total flux is just the surface integral of D evaluated throughout the entire closed surface. So kung gusto mong malaman ang flux na tumagos dito sa point na ito, kailangan mo siyang i-divide ng volume. Kaso lang, yung volume na yan ay lumiit ng lumiit. Kaya ang ginagamit natin ay delta V. It's an incremental volume. And since siya ay lumiit ng lumiit at siya ay nag-approach na sa zero, we can get the limit of this entire expression. Bakit natin ito kukuhanan ng limit? Kasi po, may quantity na nag-a-approach sa isang value. At itong delta V na ito, ang tinutukoy nating quantity. Dahil siya ay nag-a-approach sa zero. Nung ang volume, nung closed surface ay lumiit ng lumiit, nung naging point na siya, pwede nating kuhanan ang quantity na ito ng limit. Kapag ang delta V ay nag-approach sa zero. So that is the limit of this entire expression as delta V approaches zero. And this limit expression is the mathematical definition of an important and useful vector operation known as the divergence. Yes, indeed. Ayan. Itong expression na ito na ang mismong definition ng divergence. The divergence is an operation in vector calculus which is denoted simply by div. Okay? Ayan. So, yung divergence, yan ay div. And since here, the vector quantity involved is D, which is the electric flux density, then this entire expression can simply be written as div D. Okay? So, there you go, guys. This is the definition of the divergence, and since the vector involved is D, this can simply be written as the div of D. And this div of D represents the divergence of D. The divergence can also be expressed using the vector differential operator or simply the del operator. If you recall, the symbol for the vector differential operator is the inverted delta. This symbol is called nabla, which represents our vector differential operator or simply the del operator. Therefore, the divergence of vector A is equal to del dot A. So, the divergence of A is equal to del dot A. So, if you notice, the divergence involves a dot product. It is del dot A. So now, how do we define the divergence of A? To define the divergence of A, let's just copy this expression and replace this D with A. So this is now the definition of the divergence of the vector A. The divergence of vector A written as del dot A is equal to the limit of this entire quantity, the closed surface integral of the vector A over delta V as delta V approaches zero. And since this is a definition, you should always remember this and remember it by heart. For analogy, let us recall the definition of the derivative of the function y with respect to x. So dy over dx is defined as the limit of delta y over delta x as delta x approaches zero. In the same way, this divergence, which is a vector operation, del dot A is defined as the limit of this quantity divided by delta V as delta V approaches zero. O, diba? Same lang sila ng format. Pero yung derivative na iyan, yung delta Y over delta X, yan ay slope. At kapag ang delta x ay nag-approach sa zero, yung line ay nagiging tangent line. That is why we interpret the derivative as the slope of the tangent line. Okay? But now, how do we interpret this divergence? So, if this is the mathematical definition of the divergence, ano naman ang ating interpretation sa kanya? What is our physical interpretation of the divergence? This quantity represents electric flux. Electric because the vector involved is electric flux density. But for a generic vector A, this quantity the closed surface integral of the vector represents the flux of that vector. This quantity represents the flux of the vector A. Bakit? Because mathematically speaking, the surface integral of a vector is the flux of that vector. So this numerator simply represents the flux of the vector A. And this is volume. So we now have the flux per unit volume. Okay? And since this delta V approaches 0, then that volume ultimately becomes a point. So now how do we interpret this? Okay, to interpret the divergence, that is just the flux per unit volume at a point. Bakit po at a point? Kasi po, nung ang delta V ay nag-approach sa 0, yung closed surface ay naging isang point, no? Na wala namang volume. That is why this divergence of vector A can simply be interpreted as the flux per unit volume of that vector at a point. So in general, we can say that the divergence of a vector is the net outflow of flux per unit volume at a point. Why? Because from the very definition of the divergence, this quantity in the numerator is the flux divided by the volume. So that is the flux per unit volume at a point. Because this delta V approaches 0 in order for this closed surface to become a point. So we say that the divergence is the net outflow of flux per unit volume at a point. Another important thing is that when you get the divergence of something, that something must be a vector. Okay? So that means there is no such thing as the divergence of a scalar. Okay? When you get the divergence of something, that something is always a vector. And when you get the divergence of a vector quantity, you always get a scalar quantity. Okay? Why? So the clue here is the dot product. Remember that the dot product of two vectors always yields a scalar. And in the same way, the divergence, which makes use of the dot product, always yields a scalar quantity. So, tatandaang mabuti, ang divergence ng isang vector ay laging scalar at hindi pwedeng kuhanan ng divergence ang isang scalar quantity. Now, ngayon, kung ang nakukuha pala natin kapag kumukuha tayo ng divergence ng isang vector ay laging scalar, then there are three possibilities. Ano? Kapag scalar ang nakuha mo, tatlo lang ang posibleng mangyari. That scalar could be negative, it could be positive, or it could be zero. Diba? So ano ang ibig sabihin kapag ang nakuha kong divergence ay positive? Anong ibig sabihin kapag ito ay negative, and what does it mean if the divergence of a vector is 0? Let's find out. Okay, so this is an example of positive divergence. If you get the divergence at a point, halimbawa itong point na ito at positive ang iyong sagot, ganyan ang itsura ng flux. So that means that kapag positive ang divergence, that point is a source of flux. Sa point na iyon, may flux na nanggagaling or nag-e-emanate. So once again, if at a point the divergence is positive, then that point is a source of flux. So dun sa point na yon may field na nanggagaling. Okay, so that could be electric field or whatever vector field involved. Now, ano naman ang itsura kapag ang divergence sa isang point ay negative? O di ba, baliktarin mo lang yan. Kung negative ang divergence dito sa point na ito, instead of having this flux drawn away from that point, the flux will be drawn towards the point, just like this. So this now is an illustration of the negative divergence. Kapag sa isang point, ang divergence ay negative, ang mga flux ay papunta sa point na iyan. Okay? And we say that that point is a sink. If this point is called the source, this point, because its negative divergence, is called a sink. Bakit naman siya tinawag na sink? Parang sink lang yan or drain sa lababo. No? Dun sa butas ay may pumapasok na tubig. In the same way, kapag sa isang point, negative ang divergence, it is a sink because may mga flux na pumapasok sa kanya. May mga flux na nagsisink papunta sa kanya. O, di ba? So, kapag positive divergence, source. Kapag negative divergence, sink ang tawag natin. So, ang halimbawa niyan is kapag meron kang bola, no? At yung bola ay may butas. So, kung ikaw ay nasa labas ng bola, ang tingin mo, yung butas na yun, may lumalabas na hangin. So, the divergence of the velocity vector at that point, which is yung butas, is positive. Kasi ang tingin natin, may lumalabas na hangin doon. Pero, kapag ang point of view mo, nasa loob ka ng bola, no? If your point of view is inside the ball, then at that point, may pumapasok na hangin. Kaya, ang divergence at that point, kung ikaw ay nasa loob, ay magne-negative. Okay? So, depende iyan kung ano ang view mo sa point na iyon. Kung sa point na iyon ay may lumalabas na flux, then positive ang divergence doon. At kapag sa point na iyon ay may flux na pumapasok, then that is a sink. And the divergence at that point is negative. Now, paano naman kapag sa isang point, ang na-compute natin na divergence ay 0? So, if at a point the divergence is 0, that means that lahat ng flux na pumasok sa kanya ay lalabas din. So, kung may 4 na flux na pumasok, may 4 na flux na lalabas. So, that means that at a point where the divergence is 0, the net flux is always 0. And a vector whose divergence is 0 is called a solenoidal vector. So, if that is a field, then that field is described as a solenoidal field. Bakit siya tinawag na solenoidal? Kasi yung shape ng kanyang flux ay nagre-resemble sa electric field ng isang solenoid. Okay? So, ano ba ang itsura ng solenoid? Yung solenoid kasi, yan ay parang isang spring, no? Na may dumadaang kuryente. Ganyan siya. Now, ang itsura ng kanyang magnetic field ay ganito. Ayan. Solenoidal. Okay? Kaya siya tinawag na solenoidal. Kasi yung shape ay solenoidal. Okay? So, kapag ang shape pala ng field mo ay solenoidal na ganito, then ang divergence niyan ay 0. Bakit? Kasi ganito yan eh. To illustrate that, let us imagine a closed surface. So, halimbawa, ito yung closed surface mo. Ano ang net flux through the surface? Lahat ng flux na pumasok dito, 1, 2, 3, ay lumabas din. Kaya ang net flux ay 0. Okay? So, if the net flux is 0, then we say that the divergence of that vector is also 0. And it is said to be a solenoidal vector or a solenoidal field. Now, let's talk about solenoidal fields. So, once again, ano yung mga solenoidal fields? Yan ay mga fields or vector fields na ang divergence ay 0. Minsan, tinatawag din silang continuous fields. Continuous. Or if the vector quantity involves a fluid, then that fluid is described as an incompressible fluid. And the vector is an incompressible vector. So here are some examples of vector fields na divergenceless o 0 ang divergence. Kapag meron kang isang incompressible fluid, yung divergence ng velocity field ay laging 0. So to write it down, the divergence of the velocity v as a vector is always 0. So, tatandaan natin sa fluid mechanics. Kapag ang fluid ay incompressible, remember, an incompressible fluid is an ideal fluid. So, for an ideal fluid, which is incompressible, ang divergence ng velocity ay laging 0. Another example, this time in the field of electromagnetics, if we have a region of space that is free of electric charges. So, wala daw electric charge na makikita doon sa region na yon. Ang divergence ng electric field ay equal sa 0. So, kung isusulat natin yan, the divergence of the electric field intensity or simply electric field is equal to 0. Again, but there is a condition, no? So, yung divergence ng ay 0 if the region is neutral. Meaning, walang charge doon sa region or kung may charge man ang net charge ay 0. Okay? Now, you may wonder, what if doon sa region of space na iyon ay may mga electric charges? Okay? What if there are electric charges present in a region of space? Ano kaya ang mangyayari sa divergence ng E? So, in the next slide, let us discuss what will happen if we get the divergence of the electric field in a region where there are electric charges. Para mahanap natin ang divergence ng D sa isang region na may nag-e-exist na mga electric charges, consider this ang walang kamatayang closed surface na kulay blue. So ito ngayon yung electric charge na nasa loob ng closed surface. At dahil may charge, mayroong electric field, no? Represented by D, which is the electric flux density. Remember that D and E are related by the constitutive relationship D is equal to epsilon naught multiplied by E. So we use D for convenience. However, this D can be thought of as our electric field. And because we have electric field, we will also have electric field lines. Ayan, itong mga lines na to, yan yung electric field lines na tinatawag nating electric flux. Ngayon, kapag kinuna natin ng divergence ang D, in the presence of these electric charges, ano kayang quantity ang ating makukuha? So if you recall the definition of the divergence of a vector, that is just the limit of the flux per unit volume at a point. So once again, this numerator represents the flux of this vector. What is the flux of D? The flux of D is electric flux. So this means that this quantity is electric flux divided by the volume. So anong quantity yung electric flux per unit volume? Parang wala naman tayong alam na ganyan, di ba? However, we may recall Gauss's law. Ano ang sabi ng Gauss's law? Gauss's law tells us that the flux equals the charge enclosed. So this quantity here in the numerator is the flux. So essentially, this is the flux per unit volume, but we don't know any quantity that is equal to flux per unit volume. However, Gauss's law tells us that the flux is equal to the charge enclosed. And because of that, we can think of this as equal also to the charge. So that means I can rewrite this as the limit of the charge per unit volume as the volume approaches zero. Okay? Because again, according to Gauss's law, the flux, ito yung flux, is equal to the charge enclosed. So now we have the quantity charge per unit volume. Meron ba tayong quantity na charge per unit volume as delta V approaches zero? Yes. And this is actually the charge per unit volume. Ano ba ang tawag mo doon sa charge per unit volume? In electromagnetics, how do we call the charge per unit volume? Okay, which we can write as dq over dv. Ano nga yung quantity na dq over dv kung nare-recall mo? Yes, tama yan. Yan ang volume charge density. So therefore, this quantity is equal to rho v. The divergence of D is equal to rho v. Ayan. Ngayon, nabigyan na natin ng physical interpretation ang divergence ng D. Ang divergence of D pala ay equal sa rho v, which means kapag kinunan mo ng divergence ang electric flux density, ang makukuha mong quantity ay volume charge density. And this equation, div of D or the divergence of D equals rho v is a very significant equation in electromagnetics. Why? Because this is one of Maxwell's equations. So di ba alam natin meron tayong 4 na Maxwell's equation? Ito ang isa sa 4 na Maxwell's equation. At ang Maxwell's equation na iyan ang nagre-represent sa Gauss's law. This is the point form of Gauss's law na ide-derive natin formally gamit ang susunod na concept na ating pag-aaralan. So dito, nagkaroon tayo ng Maxwell's equation kasi nag-analyze lang tayo ng unit. Itong flux na to, according to Gauss's law, is equal to the charge enclosed. That is why pinalitan lang natin siya ng Q. Ano ba yung charge per unit volume? That is the volume charge density rho v. Okay, that is why we are now able to come up with this equation. The divergence of D is equal to rho v, the volume charge density. At itong equation na ito, yan ay Gauss's law din, no? Ito ang Maxwell's equation ng Gauss's law. So ngayon, paano natin ito i-derive formally? Hindi by means of inspection, kasi dito by inspection lang yung ginamit natin eh. kailangan muna nating matutunan yung isang napaka-relevant at important at useful na concept, lalo na dito sa Gauss's law. Yun ang concept na tinatawag na Divergence Theorem. At ide-derive natin itong equation na ito gamit ang Divergence Theorem. So ano naman yung Divergence Theorem na yan? So once again, let us imagine that we have a closed surface here. Ang walang kamatayang blue surface and a vector field A. Ayan. So hindi na D yung ginamit ko. Ginawa ko na siyang generic. So instead of using D, this time I used a generic vector field A. Now let this ds be the area vector of the closed surface, and we know that this area vector is always normal to the surface. To get the total flux of A through the entire closed surface, we need to evaluate the surface integral of A, right? Okay, so ito yung flux nung A, at para yan ay makompute natin mathematically, simple lang. I-calculate mo lang ang kanyang surface integral. So ito yung surface integral nung A na nagre-represent sa kanyang flux. Because mathematically, the surface integral of a vector is its flux. Now, what does the divergence theorem tells us? The divergence theorem tells us that this flux is equal to the divergence of the vector na inintegrate dun sa volume na nasa loob ng closed surface. Ulitin ko ha. Okay, the divergence theorem tells us that this flux, which is the surface integral of a vector, is also equal to the volume integral of the divergence of A. So here, we have a volume integral, ano? Kasi div ito. So this means triple integration ito. Yun palang surface integral ng vector, kung sarado or closed ang surface, equal din sa volume integral ng divergence ng vector na yon. So, let us now write the divergence theorem formally. Okay? Simple lang naman yan. Anong ibig sabihin yan? The integral of this. Anong ibig sabihin ito? Nung nag-dot product tayo, A.ds, kinuha natin yung component ng A na parallel sa ds. But since this ds is always normal to the surface, then yung component ng A na ginamit natin ay normal din sa surface, kagaya ng ds. So, this means that the integral of the normal component of A through a closed surface is equal to the integral of the divergence of that same vector evaluated throughout the volume. Where? Nasaan ang volume na ito? Itong volume na ito, yan yung volume na nasa loob ng closed surface. So, this is your divergence theorem. Ayan, the integral of the normal component of any vector that is generically represented as A over a closed surface equals the integral of the divergence of this vector field throughout the volume that is enclosed by the surface. So, mahalaga dito, dapat ang surface ay closed. So, the divergence theorem will not work if the surface is not closed. Okay? So, once you have a closed surface, you can evaluate the surface integral of a certain vector over that entire closed surface, and that is also equal to the volume integral of the divergence of that same vector. So, mahalaga lang na ating i-take note na yung left-hand side ay surface integral, samantalang yung right-hand side ay volume integral. At ang volume na tinutukoy dito ay ang volume na nasa loob ng closed surface. O, di ba? So, sir, parang ang hirap naman yan. Hindi yan mahirap. Madali lang yan. Sir, is there a simpler way kung paano natin i-rewrite or i-state yung divergence theorem na yan? Yes, actually. Why? Because this entire expression, remember, represents what? Ang entire expression na ito, anong nire-represent niya? This is simply the flux of the vector A. Okay? And this is the volume integral of div A, right? So we can simply write this expression in this way, no? the net flux of a vector, ito yon, the net flux of a vector through a closed surface equals the volume integral, ito yon, of the divergence of that vector. Okay? So, yan yung mas pinaikling statement ng divergence theorem. So, kinakailangan lang i-consider mo na yung volume integral na tinutukoy dito ay yung volume na nasa loob ng closed surface. O, di ba? Madali lang yung divergence theorem na yan. Mukha lang siyang komplikado pero madaling unawain. No? Now, ano naman ang kahalagahan ng divergence theorem para naman ito saan? Ano naman ngayon? Kung ito ay equal doon, napakahalaga nito. No? Bakit? Because it permits us to convert a surface integral into a volume integral. Sir, may tanong ako. Bakit mo naman i-convert ang surface integral sa volume integral? Kasi minsan may problem na mahirap i-evaluate ang surface integral kasi maraming surfaces involved. Halimbawa, meron kang cube. So, alam naman natin yung cube, ganito itsura niya. Pangit ako mag-drawing. 6 ang kanyang surfaces. 'Di ba? So, kung 6 ang kanyang surfaces, para ma-evaluate mo to, magko-compute ka ng 6 na double integral. O 'di ba, dun pa lang komplikado na 'yon. 6 na double integral. So if that is somewhat tedious, no, or time consuming or difficult, then there is an option for you to get the answer, the same answer, using a simpler alternative. That is to convert the surface integral into a volume integral using the divergence theorem. So kung magko-compute ka ng volume integral, ano ang kukunan mo ng volume integral? Hindi yung A, but rather divergence ng A. Ayan. So kung surface integral, ang kukunan mo ng surface integral ay ang vector. Pero kung mahirap gawin ang surface integral, i-convert mo siya sa volume integral. Pero ang kukunan mo ng volume integral ay ang divergence ng A. Pero sir, di ba yan ay triple integral? Yes, kasi volume integral siya. Pero isang triple integral lang yan kumpara sa 6 na double integrals. Yung isang double integral pa nga lang, papatay ka na . How much more kung 6 yung double integral na evaluate mo? So, medyo matrabaho yun. Okay? Kaya ang alternative is, i-convert mo ang surface integral into a volume integral gamit ang divergence theorem para mapadali yung trabaho. O, di ba? So, yan yung gamit ng divergence theorem. Or, kung nahihirapan kang i-evaluate ang volume integral, ito mismo yung problem. Kasi hindi mo alam kung paano kumuha ng divergence. No, ang gawin mo na lang, i-convert mo na lang siya into a surface integral if that is easier for you. Okay? Kalimbawa, kasi kapag sphere ang involved, kung sphere yan, alam naman natin yung surface niyan ay iisa lang. No? Yung surface ng sphere, unlike this na may 6 na surfaces. So, kapag sphere, at hindi ka marunong mag-divergence, mas madaling i-evaluate ang surface integral kumpara sa volume integral. Bakit? Kasi nga, hindi ka marunong mag-divergence. Pero kung marunong ka namang mag-divergence, edi mako-compute mo yung volume integral niya. Okay? Pero kung hindi mo makompute dito, you can convert it or you have the option to convert it into a surface integral kung saan mas madali mo siyang mai-evaluate. Di ba? Powerful yung divergence theorem na yan. Ngayon, saan natin yan gagamitin? Gagamitin natin yan sa pagdiderive ng Gauss's law. So, ibig mong sabihin, sir, itong divergence theorem related sa Gauss's law? Yes. At itong divergence theorem na yan ay dinevelop ni Gauss. At tinatawag din siya na Gauss's theorem. So, do not confuse Gauss's theorem and Gauss's law. Gauss's theorem is for mathematics and Gauss's law is for electromagnetics. So, bakit ngayon yung Gauss's law ay tinawag na Gauss's law? Di ba? That is because of the works of Gauss. Yung na-formulate niya na divergence theorem ang naging dahilan kaya na-express natin mathematically yung Gauss's law. At yun ang ating i-derive ngayon. Ano ang mathematical expression ng Gauss's law na ikino-consider as one of the 4 Maxwell's equations? Now, let us recall Gauss's law. Remember, according to Gauss's law, that the flux is equal to the charge enclosed. And the flux is equal to the surface integral, right? Ito yon, surface integral ng D. Samantalang yung total charge ay volume integral naman ng charge density. So this is just your Gauss's law in integral form. So this equation is just the integral form of Gauss's law. And Gauss's law involves a closed surface integral na pwede nating applyan ng divergence theorem. Diba? Ano nga ulit yung divergence theorem? Sulat natin. For a generic vector field A, divergence theorem can be expressed as the closed surface integral of A is equal to the volume integral of the divergence of A. O, diba? So, kung gusto nating applyan ng divergence theorem ang left-hand side ng Gauss's law, papalitan lang natin ng D yung A dito sa divergence theorem. And also, this A, we will replace it with D. Okay? And we will get this. Ayan. So, upon the direct application of the divergence theorem to Gauss's law, we get this expression. The closed surface integral of D is equal to the volume integral of the divergence of D. Now, itong left-hand side na ito equal sila. That means that their right-hand sides must also be equal, right? So, kung ito ay integral at ito ay integral, ito ay dv at ito ay dv, then that means that this divergence of D must be equal to rho v, right? Yes. And now, we have this. The divergence of D is equal to rho v at yan ang equation na gusto nating i-derive. Ito ang tinatawag na point form or differential form ng Gauss's law. So that means that these two, itong equation na ito at ito, iisa ang ibig sabihin, no? Ito naka-integral form lamang at ito naka-differential form. At yung differential form tinatawag din na point form kasi pwede mo siyang i-evaluate at a point. Unlike this, kasi yung integral point, may limits yan. Kaya hindi mo siya ma-evaluate sa isang point. No? That is why in some cases, mas useful ang point form. Kasi kapag ginamit mo ang point form, pwede tayong mag-evaluate ng quantity at a given point. Halimbawa, ang quantity na gusto mong kuhanan ng divergence ay D. So pag kinuha mo ang divergence ng D at a point, ang makukuha mo is yung rho v or yung volume charge density at that point. At kung matatandaan ninyo, ito rin yung na-derive natin kanina or nakuha natin kanina by means of expansion na tinatawag nating Maxwell's equation. So yan ang Maxwell's equation na nagre-represent sa Gauss's law. O, di ba? So nakaisa na tayo sa apat na Maxwell's equation. Now, this equation can also be written in terms of the electric field intensity. Right? Bakit? Kasi po, alam natin yung D at saka E ay related, di ba? In free space, D is equal to epsilon naught times E. So if you want to use the electric field instead of D, then the divergence of the electric field is equal to this rho v, the volume charge density, divided by the permittivity of free space, epsilon naught. O, di ba? So, ito at saka ito parehas lang din yan. Kaso nga lang dito, electric flux density ang ginamit natin. Ito naman, electric field intensity yung ginamit. Now, how do we interpret this equation? No? Ano ang gustong sabihin sa atin ng equation na iyan? Simple lang. Kapag sa isang point ay mayroong electric charge na present, ayan, kasi this volume charge density represents the charge. Kapag sa isang point ay may charge, then sa point na yon may electric field na manggagaling. So if that charge is a positive charge, then electric field must be emanating from that point. So this equation implies that electric fields, ito yun, no? Electric field, or this can be thought of the electric field, no? Emanate or diverge from a point where there exists a positive charge density. So, kapag sa isang point, mayroong charge na positive, dun sa point na yon may mag-emanate na electric field. Paano kung sa point ay may negative na charge? O di sa halip na yung electric field ay nag-emanate sa kanya, ito yon. Di ba kanina kapag positive ang divergence, ganyan ang itsura. So if at a point, the divergence is negative, then sa point na yon, that is considered a sink. No? Yung electric field is directed towards that point. So ano pa ang gustong sabihin sa atin ng Gauss's law? No, particularly itong equation na ito. Simple lang, no? 'Di ba itong electric field 'yan at itong rho v, 'yan ay charges, no? This is the charge and this is electric field. So that means, saan daw nanggagaling ang electric field? Ang electric field ay nanggagaling sa mga electric charges. Okay? So in summary, this Gauss's law tells us that electric charges are the sources of electric fields. Yun lang. Mahalaga to. So that means, basta may electric charge, no, matik, may electric field. Bakit? Kasi ang electric field ay nanggagaling sa mga electric charges. Kung positive ang electric charge, dun sa charge na yon, may mag-e-emanate na electric field. At kung ang charge naman ay negative, dun sa point na iyon, ang electric field ay directed towards it. Okay? So yun lang, no? Yan ang gustong sabihin sa atin ng Gauss's law. Electric charges are the sources of electric fields. O, di ba simple lang? So, ngayong alam na natin kung ano ang ibig sabihin ng divergence. Alam na rin natin yung Divergence Theorem. At ginamit natin ang Divergence Theorem para ma-derive ang isa sa Maxwell's equation. Yung Maxwell's equation na nagre-represent sa Gauss's law. Ang susunod nating aaralin is, paano ba kumuha ng divergence ng isang vector? O, di ba? So if we have a three-dimensional vector expressed in rectangular or cylindrical or possibly spherical coordinates, paano natin i-evaluate yung divergence ng vector na ito? Unahin natin yung rectangular or Cartesian coordinates. Okay, so here we have the vector A, and the divergence of vector A in rectangular coordinate is just the partial derivative of ano ba itong AX, AY, and AZ? Yan yung vector components. So, kukunan mo lang ng partial derivative yung mga vector components. So, kung yun ay vector component along X, kukunan mo ng partial derivative with respect to X. And you do the same for all the remaining vector components. The partial derivative of the vector component along Y with respect to Y, and the partial derivative of the vector component along Z with respect to Z. And remember that the divergence of a vector is always a scalar. Kaya, wala kang makikita ditong unit vectors na AX, AY, and AZ. Okay? So, ang sagot na makukuha mo dyan ay scalar, which is either positive, negative, or zero. Now, what if our vector is expressed in cylindrical coordinates? The divergence of a vector in cylindrical coordinates is given by this expression. So, in cylindrical coordinates, what are our space variables? A point in cylindrical coordinates is represented by rho, phi, z. So, rho is the radial distance, phi is the azimuth angle, and z is the same as the coordinate z in rectangular coordinates. So, we have 1 over rho times the partial derivative with respect to rho of rho times a rho. Ayan. So, kung dito, meron kang divisor na rho, dapat yung kukunan mo ng partial derivative, may multiplier naman na rho. O, di ba? Madaling tandaan. Plus, dito, 1 over rho. Pero dito, wala nang multiplier na rho. Kanina, may divisor na rho. And then, yung kukunan mo ng partial derivative, mayroong rho. Diba? Dun sa pangalawa, may divisor ka pa rin na rho, pero yung kukunan mo ng partial derivative, wala nang multiplier. It's just the vector component along phi. Of course, with respect to phi. Plus, yung pangatlong term, wala nang multiplier. Normal lang. Bakit? Kasi nga, yung z ay kagaya lang ng z sa rectangular or Cartesian. Kaya kung ano yung term niya para sa z, kokopyahin mo lang din. Ayan, partial derivative ng vector component along z with respect to z. Now, how about kapag spherical ang ating coordinate system? So, kapag spherical ang coordinates, ano ang space variables natin? We have r, theta, and phi. Yung phi dito, kagaya lang ng phi sa cylindrical. Diba? So, the divergence of a vector in spherical coordinates is given by 1 over r squared times the partial derivative with respect to r of o. Pansinin mo, kagaya ng format dito, no? Kung ano ang divisor sa labas, yun ang multiplier sa loob, no? So, ang divisor natin dito, r squared, ang multiplier sa loob, r squared. So, dahil yan ay with respect to r, dapat dito ar. And then 1, yan, plus. 1 over r sine theta times the partial derivative with respect to theta of a theta. Kaso nga lang may multiplier na sine theta. So, hindi mo isasama yung r. Kung ang divisor mo dito ay r sine theta, ang multiplier mo, yun lang sine theta. Plus, 1 over r sine theta, ito lang din, kagaya lang din niya. 1 over r sine theta times the partial derivative with respect to phi of a phi. So, di ba itong rho, kapag kinonvert natin sa spherical coordinates, ay magiging r sine theta. That is why 1 over rho, which is r sine theta. And then, kinopya mo lang to, the partial derivative of a phi with respect to phi. So, kinakailangan sa ulado natin yan or memorize natin. So, I suggest na para ma-memorize mo, isulat mo siya ng maraming beses. Halimbawa, ito, sulat mo ng 5 times. Ito, sulat mo ng, mas mahirap to, no? Gawin mo 6 times or 7 times. Basta, many times hanggang sa ma-memorize mo yung formula. Okay? So, ngayon, alam na natin yung formula sa pagko-compute ng divergence. Mag-solve na tayo ng mga examples.